Hey everyone, welcome to Hazel Math. In this video, I will be going over questions 1 to 25 of the Gauss Grade 7 2018 competition. So let's get right to it. Question 1. What number should be subtracted from 21 to give 8? So let's let this number be x. So 21 minus x equals to 8. So x equals to 21 minus 8. So x would equal to 13. So B is the correct answer. In the diagram, the pie chart shows the results of a survey asking students to choose their favorite fruit. 100 students were surveyed. How many students chose banana? So banana, as you can see, is 20%. So 20% multiplied by 100 equals to 0.2 multiplied by 100, which equals to 20. Therefore, D is the correct answer. Number 3. A class begins at 8:30 and ends at 9:05 a.m. on the same day. In minutes, what is the length of the class? So from 8:30 to 9 is 30 minutes. And from 9 to 9:05 is 5 minutes. If you add them together, it's 35 minutes. Therefore, C is the correct answer. Number 4. A square has an area of 144 centimeters squared. The side length of the square is, so the area of a square is the side length squared. And since you know the area of the square is 144 centimeters squared, which equals to the side length squared, you can square root both sides and get that S equals to 12 centimeters. Therefore, D is the correct answer. Number 5. If there is no tax, which of the following costs more than $18 to purchase? So 5 $1 items and 5 $2 items. That gives you 5 times 1 plus 5 times 2 equals to 15, which is smaller than 18. 9 $1 items and 4 $2 items. So 9 times 1 plus 4 times 2 equals to 17, also smaller than 18. This is 9 times 1 plus 5 times 2, which is 19, which is bigger than 18. So this should be the right answer, but let's just check the other two. So 2 $1 items and 6 $2 items. 2 times 1 plus 6 times 2 equals to 14, smaller than 18. 16 times 1 plus 0 times 2 equals 16, also smaller than 18. So it's been confirmed that C is the correct answer. Number 6. Which of the following numbers lie between 3 and 4 on a number line? So A, you get equals to 2 and 1 over 2. B equals to 2 and 3 over 4. C is 2 and 1 over 5. D is 3 and 1 over 4. And E is 2 and 3 over 5. And you realize that all of these numbers are smaller than 3 except for D. And D is between 3 and 4. So D is the correct answer. Number 7. An envelope contains 2 sunflower seeds, 3 green bean seeds, and 4 pumpkin seeds. Carrie randomly chooses one of the seeds from the envelope. What is the probability that Carrie chooses a sunflower seed? So you want the probability of a sunflower seed, so that's 2 over 2 plus 3 plus 4. So this would equal to 2 over 9. So A is the correct answer. Number 8. If x is 4 and y equals to 3x, then the value of y is, so y would equal to 3x, which equals to 3 times 4 as given by the question, which equals to 12. So A is the correct answer. Number 9. The measure of one angle of an isosceles triangle is 50 degrees. The measure of the other angles in this triangle could be, so there's really only 2 scenarios for an isosceles triangle with an angle of 50 degrees. The first scenario is if the top part is 50 degrees. The second scenario is if the angles that are equal, one of them equals to 50 degrees. In this case, this would also have to equal to 50 degrees. And since the total angle of a triangle, the sum is 180, this angle would be 180 minus 50, which equals to 80 degrees. And if you see, we do have the option of another 50 degree and 80 degrees. So this should be the correct answer, but let's check the first scenario. So if this first scenario were true, then the other angle, such as this one, will be 180 minus 50 divided by 2, which would give you 65. And if you see, there are no 65s in A, B, C, D, or E, so C is the right answer. Number 10, the 26 letters of the alphabet are written in order clockwise around a circle. The ciphertext of a message is created by replacing each letter of the message by the letter that is 4 letters clockwise from the original letter. This is called a Caesar cipher. For example, the message ZAP has ciphertext DET. What is the ciphertext of the message WIN? So WIN, and then you have 1, 2, 3, 4. So WXYZA, IJKLM, and then NOPQR. So the answer is AMR. So C is the correct answer. Question 11. A cube has exactly 6 faces and 12 edges. How many vertices does a cube have? So I'm just going to draw out a cube and count how many vertices it has. So 1, 2, 3, 4, 5, 6, 7, 8. Therefore, the correct answer is E. Number 12. What is the surface area of a 1 centimeter by 2 centimeter by 2 centimeter rectangular prism? So the surface area would equal to 2 times 1 times 2 plus 1 times 2 plus 2 times 2. And this gives me 16. So E is the correct answer. Number 13. At a factory, 11,410 kilograms of rice is distributed equally into 3,260 bags. A family uses 0.25 kilograms of rice each day. How many days would it take this family to use up 1 bag of rice? So the first thing I'm going to do is find how many bags of rice there are, how many kilograms there are in each bag. So that's 11410 divided by 3260. So this is how many kilograms of rice there are in each bag. And then I want to find how many days it takes for this family to use up 1 bag of rice. So I'm going to divide this number by 0.25. And this gives me 14. So D is the correct answer. Number 14. Dahlia's birthday is on a Wednesday and Bruce's birthday is 60 days after Dahlia's. On what day of the week is Bruce's birthday? So we know that in a week there are 7 days. So 60 divided by 7 equals to 8 remainder 4. And the days of the week are Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And you know that Dahlia's birthday is on a Wednesday. So if Dahlia's birthday is here, then we count 4 days after that. So 1, 2, 3, 4, Sunday. Therefore, Bruce's birthday is on a Sunday. Number 15. Carl has 30 birds. Some of his birds are emus and the rest are chickens. Carl hands out 100 treats to his birds. Each emu gets 2 treats and each chicken gets 4 treats. How many chickens does Carl have? So I'm going to let E equal to represent the number of emus and C represent the number of chicken. Then from that I get the equation E plus C equals to 30 because he has a total of 30 birds, and 2E because each emu gets 2 treats plus 4C because each chicken gets 4 treats equals to 100 because in total he has 100 treats. And I'm going to play around with these two equations to get C. So first I'm going to express E in terms of C. So E equals to 30 minus C. I'm going to use this equation, plug it into here. So E multiplied by 30 minus C plus 4C equals to 100. From this, I get that 60 minus 2C plus 4C equals to 100. So 60 minus 2C equals to 100. 2C equals to 100 minus 60, so then C equals to 20. Therefore, D is the correct answer. 16. The integers 1 to 32 are spaced evenly in an order around the outside of a circle. Straight lines that pass through the center of the circle join these numbers in pairs. Which number is paired with 12? So I'm going to do 12 plus, and since we know that these paired numbers are directly across each other, I'm going to do 32 divided by 2. That gives me 12 plus 16, which equals to 28. Therefore, A is the correct answer. 17. In the diagram, the area of the shaded middle ring is 6 times the area of the small circle. The area of the unshaded outer ring is 12 times the area of the small circle. What fraction of the area of the larger circle is the area of the smallest circle? So I'm going to first set the smallest circle as an area of 1. Therefore, I know that the shaded region has an area of 6, and the largest outer unshaded region has an area of 12. And since I want to know the fraction of the area of the larger circle is how much of it is the area of the smaller circle, I'm going to do the area of the smaller circle over this entire circle's area, which is 1 plus 6 plus 12, which equals to 1 over 19, giving me the answer of E. 18. There are several groups of 6 integers whose product is 1. Which of the following cannot be the sum of such a group of 6 integers? If you think about it, the integers who multiply each other, whose product is 1, is really only 1 times 1, giving you 1, and negative 1 times negative 1, also giving you 1. But you also know that negative times negative is positive, but negative times negative times negative is negative. And the first thing that jumps out to me is number C, 0, because if you think about it, you have to use the integers 1 and negative 1 only to add up to 0, but whose product is also 1. So if I want the sum to be 0, I'd have to do negative 1 plus negative 1 plus negative 1 plus 1 plus 1 plus 1, which equals to 0. But negative 1 times negative 1 times negative 1 times 1 times 1 times 1 does not equal to 1. It equals to negative 1. For any group of integers whose sum is 0 and product is 1, you know you have to have the equal number of negative 1s and 1. But since you have 6 integers, and 6 divided by 2 is 3, which is an odd number, and since you know that 3 negative numbers multiplied to each other equals to negative, you know that the product cannot be positive and it must be negative 1. So C, 0 is impossible. So question 19. The heights of 4 athletes on a team are 135 centimeters, 60 centimeters, 70 centimeters, and 75 centimeters. Larissa joins the team. On the new team of 5 athletes, the mode height of the players is equal to the median height, which is equal to the mean or the average height. How tall is Marissa? So since on this team you have 4 numbers that are none of these numbers are equal to each other, we know that at the present we have no mode. Therefore, we know that Larissa's height has to be one of these 4 numbers. But let's first set the equation. So 135 plus 160 plus 170 plus 175 plus, let's let Larissa's height equal to x over 5 equals to x, because you know that the mode is equal to the mean or the average. If you rearrange this equation, you get 640 plus x equals to 5x, 4x equals to 640, so you know that x equals to 160. So then B is the correct answer. Question 20. In the diagram, triangle PQR is isosceles with PQ equals to PR. What is the value of x? So the first thing you do is label the isosceles to 2 sides that are equal. And then we're going to look further into the angles. So you know that this is a straight line. So in total, it's 180 degrees. And since you know that this angle is 120 degrees, this angle is 180 minus 120, which equals to 60 degrees. Same thing with this line, it's 180 degrees, and you already have 95 degrees. So this is 180 minus 95, which equals to 85 degrees. And because you know that the total angle, the sum of all the angles in a triangle is 180, we're going to use this triangle. We know that this angle is 180 minus 60 minus 85, which gives me 35 degrees. And because this is an PQR is an isosceles triangle, this angle is also 35 degrees. So x would equal to 180 minus 35 minus 35, which gives me 110. Question 21. The figure consists of 8 identical small parallelograms joined as shown. Including these 8 small parallelograms, how many parallelograms appear in this figure? So for this question, we're just going to see the different types of parallelogram and count them. So the smallest one we have is the 1 by 1, and there's 1, 2, 3, 4, 5, 6, 7, 8 of these. Then we have the 1 by 2. We're going to count them. We have 1, 2, 3, 4, 5, 6. So you have 6 of these. Next is the 3 by 1. And if we count these, we have 1, 2, 3, 4. So we have 4 of these. And lastly, it's the 4 by 1. And we have 2 of these. Then we have the 1 by 2. And we have 4 of these. So 1, 2, 3, 4. And then we have the 2 by 2s. And we have 1, 2, 3 of these. Then we have the 2 by 3. And we have 2 of these. And then lastly, we have the 4 by 3. 4 by 2. And there's only 1 of this, which is the entire shape. Therefore, if you add up 8, 6, 4, 2, 4, 3, 2, 1, you should get 30, which is B. Question 22. In a jar, there are 50 coins with a total value of $5. The coins are quarters worth $0.25 each, dimes worth $0.10 each, and nickels worth $0.05 each. The number of nickels in the jar is 3 times the number of quarters. The number of dimes is 1 more than the number of nickels. How many quarters are in the jar? So for this question, I'm going to use Q, D, and N to represent the number of quarters, dimes, and nickels. So Q plus D plus N equals to 50, because there's a total of 50 coins. 0.25Q plus 0.1D plus 0.05N equals to 5, because the total value is $5. Then we know that the number of nickels is 3 times the number of quarters. So N equals to 3Q, and the number of dimes, so D, is 1 more than the number of nickels, equals to N plus 1. So we're going to use these 3 equations and then try to see if we can get the Q, which is the number of quarters. So I'm going to move this down here so we have more space. This is question 22. So using the very first equation, I'm going to call this 1, this 2, 3, and 4. So the first thing I'm going to do is sub equation 4 into 3. This way I get D equals to 3Q plus 1, and this is going to be equation 5. So I'm going to sub equation 5 and 3 into equation 1. So I get q plus 3q plus 1 plus 3q equals to 50. From this I get 7q equals to 50 minus 1. Then q would equal to 49 divided by 7. And q would equal to 7. So really, you didn't even need to use the second equation. And you already know that the number of quarters is 7. Therefore, the answer is A. Question 23. The digits from 1 to 9 are written in order so that the digit n is written n times. This forms the block of digits 1, 2, 2, 3, 3, 3, 4, 4, 4, 4, all the way to 9 nines. The block is written 100 times. What is the 1953rd digit written? So first thing I'm going to do is find out how many numbers there are in one block. So that's just 1 plus 2 plus 3 plus all the way until 9, which gives me 45. Then I'm going to find out how many blocks fit in to 1953 digits. So 1953 divided by 45 gives me 43 remainder 18. So now I know I have a remainder of 18, and I'm just going to write out the first 18 digits of this pattern to see what's the 18th digit, and that would give me my answer. So 1, 2, 2, 3, 3, 3, 4, 4, 4, 4, 5, 5, 5, 5, 5. So far I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So the 18th digit is 6. Therefore, the correct answer is C. Question 24. The number 2018 is used to create 6-digit positive integers. These 6-digit integers must contain the digits 2018 together and in this order. For example, 720186 is allowed, but 209318 and 210893 are not. How many of these 6-digit integers are divisible by 9? So the first thing we need to know is that any number that is divisible by 9, the sum of their digits should also be divisible by 9. So the first thing I'm going to do is to add up the digits in 2018. So 2 plus 0 plus 1 plus 8 gives me 11. So since this is a 6-digit positive integers, we in 2018 already takes up 4 of those digits. I want to look at the other 2 digits. And the largest sum they can make is if they're both 9. And if you add them up together, you get 18. So if I want to find the total number of these 6 digits, the biggest one is 11 plus 18, which gives me 29. Then I want to find all of the numbers between 11 and 29, but that are also factors of 9. So then you only get 18 and 27. So if you do 27 minus 11, you get 16. And if you do 18 minus 11, you get 7. So what I'm going to try to do here is find the 2 digits that add up together that equal to 16 and 7. So this equals to 8 plus 8, also equals to 7 plus 9. This equals to 1 plus 6, equals to 2 plus 5, equals to 3 plus 4, and equals to 7 plus 0. Then you also have to look at the different rearrangements possible, because you're not just accounting for the digits, you're also accounting for the entire number as a whole. So the placement of the digits also matter. So 8 and 8, it doesn't matter really which one you place before or after. It still gives you 8 and 8. However, 7 and 9 can also give you 9 and 7. So that's 2. 1 and 6 also gives you 6 and 1. 2, 5, 5, 2, 3, 4, 4, 3. And for 7 and 0, we're actually going to come back to that later. First, we're just going to look at these ones. And if you look at the placement, you have 6 digits. So 1, 2, 3, 4, 5, 6. 2018 can be placed in 3 different ways. You can do 2018, 2018, or 2018. So for each of these, which is 9 in total, you have 3 different placements you can make. So 9 times 3 equals to 27. But then, remember how I said we would come back to the 7 plus 0? The zeros always make a special case with digit placements, because if the 0 is the very first digit, then that makes that number not a 6-digit integer anymore. It makes it a 5-digit integer. So we have to really be careful with the zeros, and we can just list out the possible placements using zeros. So you have 2018 00, 2018 70, 7 2018 0, and 70 2018. And this also gives you 4. So 27 plus 4 equals to 31. Therefore, the correct answer is C. Question 25. In the triangle, each of the numbers 1, 2, 3, 4, 5, 6, 7, 8 is placed into a different circle. The sums of the numbers on each of the 3 sides of the triangle are equal to the same number s. The sum of all of the different possible values of s is... So the first thing I'm going to do is look at this diagram and fill in the circles by using variables. So I'm going to use A, B, C, and D, E, F, G, G, H. And then I'm going to use some equations again. So because I know that this is S, this is S, and this is also S, if I add up all 3 S's together, I get S plus S plus S equals to A, D, E, B, A plus D plus E plus B plus B, F, C, plus B plus F plus C, plus C, G, H, A, plus C plus G plus H plus A. Simplifying this, I get 3S equals to A plus B plus C plus D plus E plus F plus G plus H plus, and then the extra ones, which are A plus B plus C. And from this, you know that each one of these has to be one of the 1, 2, 3, 4, 5, 6, 7, 8. So you can just add them as a total. So 3S equals to 36 plus A plus B plus C. Simplifying the equation, you get 3S minus 12 equals to A plus B plus C. And from this, you know that this must be divisible by 3 because of this. So then I'm going to move this equation down to have more space. So question 25. And we're going to see what we can do with this. So the first thing I'm going to do is find the largest. So the largest possibility is if A, B, C is 8 plus 7 plus 6, which equals to 21. The smallest possibility is if it's 1 plus 2 plus 3, which equals to 6. And then from this, I get 3S minus 12 equals to 21, and get S equals to 19. Here is 3S minus 12 equals to 6, S minus 12 equals to 2, so S equals to 14. So we know that the options for S is between 14 to 19. So we have 14, 15, 16, 17, 18, and 19. Then we're going to see how we can work it out using the equation. So this is 3 multiplied by 4 minus 12, which is 6. 3 multiplied by 5 minus 12, 15 minus 12, which equals to 9. 3 multiplied by 16 minus 12 equals to 12. 3 multiplied by 17 minus 12 equals to 15. 3 multiplied by 18 minus 12, which equals to 18. 3 multiplied by 19 minus 12 equals to 21. And from here on out, you're going to take all of these numbers and try to see how to add them together to equal, to fit into the diagram above, like in this one. So you see that the only possibility for 14 is 1 plus 2 plus 3. For 15, you can do 1 plus 2 plus 6. For this one, you can do 2 plus 4 plus 6. This one is 2 plus 5 plus 8. This one is 1 plus 7 plus 8. And last one is 6 plus 7 plus 8. And basically, I got these numbers from fiddling around. And I'm just going to quickly draw all the diagrams for you to see. There. From that, we find that we can do all of the numbers. So this is 15, 16, 17, and 18. If the S's were 15, 16, if the S's were 15, 16, 17, and this is 19. So we find that we can fiddle around and find out 15, 16, 17, 19, but 14 and 18 seems to be a really big challenge. So we're going to go in deeper in depth to see what is the problem. So we're going to take 14 as S equals to 14 out and really analyze this. So when S equals to 14, A plus B plus C equals to 3S minus 12, which equals to 6. So the only possibility for this to work is if A plus B plus C ability is if A plus B plus C is 1 plus 2 plus 3. And if this is respective, then you know that this is A, B, and C. Then B would be 2 and C would be 3. So the only possibility, the biggest possibility for this number here is for it to be 8. But if you look at the sum of this, 2 plus 8 plus 3 is 13, which is smaller than 14. So because S is supposed to be 14 and the largest is 13, it's impossible for S in this scenario to be 14. So this S cannot be 14. Then we look at the other troublesome one, which is S equals to 18. So A plus B plus C equals to 3S minus 12, which equals to 18. So in the same similar situation where we have this diagram, you know that this is equal to B plus C plus F. Then you realize that the BC here and the BC here are equivalent. So then A must equal to F. But then if we look at the possibilities of three numbers adding up equaling to 18, you get 3, 7, 8, 4, 6, 8, and 5, 6, 7. And you realize that this just isn't possible with the overlapping ones. So you realize that 18, S equals to 18 also isn't possible. So if you go back up, what they're asking for is the sum of all the different possible values of S is. And then you look, it's 15, 16, 17, and 19. So if you add up all the possibilities, you get 67. Therefore, E is the correct answer.